Well, I have a problem where to place the basket, and I have to make a declaration of interest immediately, I think, because on the basket from one side it is written Hyundai, and from another Skoda. This is just a coincidence, because I didn't have another basket at hand, so I took the basket which was available. My work has nothing to do with Skoda. Privately, yes, we own a car, but it is not advertisement for this one. So I just have to be sure I have to change slide in a simple way, as it is always done when I have it on my computer, I think. And now I would like to thank also the head of the division where I work, functioning head, Annette, for this excellent presentation of my person, my work, which I do. And yes, I can agree that I think the background in the risk assessment of chemicals in food, especially food additives, with this group I work most, but also food supplements, and combination with the research work, which I could perform in our institute over the years, looking at the importance of dietary factors on atherosclerosis and health. And in this group for 16 years, I was working with, in fact, polyphenolic plant compounds. Their effect on atherosclerosis and cancer gives me a good background to stay here in front of you and to present my experience to the scientists in this field of the research, and also for risk assessors, risk managers, and those who are interested in marketing also food supplements for the European population. So thank you very much. And I must say that I cannot really add anything more than the two speakers, Bernard Botex and Birgit Doucemont, made, because their presentations were very extensive on this field. However, I will try to do my best to share my experience with you. So I'm going to talk about food additives, give you a definition of food additives. Then I will very slightly and generally touch the principles of risk assessment for food additives and what kind of database we need. The risk assessment step will be only really touched, and then I will explain what kind of health-based guidance value for food additives we usually have. And I am not sure if everybody understands the term health-based guidance value, because working over 25 years, you know, I was usually accustomed to other terms, and then suddenly this very fancy, for me, health-based guidance value was used more and more. So it is not a mysterious one. We know it very well from food additives and other chemicals which are added in purpose to food. Dear colleagues, food additives, very simply, they are substances which are added normally to foodstuffs for a reason. They have to perform certain technological functions. For example, we can color food with them, we can sweeten food with them, we can preserve it, and we can improve consistency of food. Just some examples. This definition is very simple and very understandable, I hope. There is a more complicated definition, but a legal definition, which you can find on the website. What is important in this more complicated definition, because it is a law language. So what we have to remember, it is, yes, it is added to food, it is consumed with food. It is not a characteristic ingredient of food. It may or may not have a nutritive value, but it is not added for this nutritional value to the food, but it is added intentionally because of the technological function it has in the food. And dear colleagues, or dear participants of this workshop, rather I should say, regardless of the technological effects of food additives, which are beneficial from technological point of view, many consumers perceive the addition of food additives as undesirable. They say this is chemistry, we need not chemistry in our food. We do not want chemical in our food. We want natural food, they say. And in fact, those who say that they would like to have natural food, they do not realize that a lot of food additives, in fact, is from natural, botanical sources. So it is not just chemistry. Let me give you some examples. For example, if we look at sweeteners, ooh, very bad sweeteners, some of them, huh? They can kill us. So, in fact, many years ago, thaumatin, which is a plant protein extracted from a plant, has been authorized as a food additive in the European Union. And now, suddenly, we have a miraculous, natural sweetener because it is from a plant. Yes, it is. However, we have to realize it is a food additive and it is a mixture. And it is a very well-defined mixture which was tested really thoroughly toxicologically before risk assessment has been performed. This mixture comprises specific glycosides from the plant, and it is not less than 95% of stevioside and or rebaudioside A. So it is not just a mixture of the glycosides from this plant, but a certain mixture. Then in other groups of food additives, for example, as gelling agents and stabilizers, there are a lot of gums which are used. And these are from botanical origin, but sometimes the source is not an edible source. Very often those are taken from either a bark of a tree or from branches, roots of plant material. So, but these are useful and these have also been evaluated for safety before authorization in European Union. And now they are under evaluation, under the program of re-evaluation of all authorized food additives. Well, I couldn't buy, dropping by to the supermarket today before coming to the conference, I couldn't find a fresh rosemary in the supermarket. However, if you are cooking, if you like lamb, probably you have used rosemary to flour your meat, and it is not a problem. It is not a problem also to use a rosemary extract, which is an authorized food additive. Foaming agents are also based on plant extracted food additives, and the example is quilila extract. And then we come to colors. We love colors in our food. Colors make our food tasty. How I can color my food? Well, here I have Madras curry. It will not only add the yellow color, nice color, but it also will make my food hot. I can also add very nice red chili, and it will also add some color, but very simply, I can use tomato concentrate, and I will get a color in my food. Similarly, what I have here, red curry paste. Dear participants, I could not find more interesting examples on the shelf, being very briefly in the supermarket. However, we can also buy, we have industrially food color additives. And, well, some would say they are natural, they are synthetic, artificial, and they are mineral. Yeah, I didn't drop by the laboratory to take a box with calcium carbonate, for example, which is used also as a color, mineral color. But are the natural color food additive really natural? Yeah, in a way they are, because they comprise colors, pigment, dyes occurring in nature as plant, animal, or even insects. Mineral products, including their synthesized natural food color forms, but synthesized, please remember. And they can be obtained also by some chemical modification of these natural pigment dyes. Well, so what we should remember about these natural colors, they can also, that they are prepared from biological sources, without major chemical alterations of original components. Very well. But there is no legal definition of natural food colors. So please remember, legally, these colors and these which a chemist synthesizes in a tube in the lab, they are treated in the same way when they have to be assessed for safety. Examples of the colors. Now I showed you some preparations of the color or vegetable sources, but now here they are food additives, curcumin, chlorophylls, mixed carotenes, for example, paprika extract, beetroot red from beetroot, anthocyanins, which we can find in berries, and vegetable carbones, which is obtained from different vegetable sources. Some of those are from, most of them, from edible sources, but for example, lutein can be also obtained from a flower plant, tagetes. So, not only usually edible sources can be used to make the food additives. However, they are all food additives. No difference if they are natural or synthesized. And risk assessment of food additives in the European Union follows certain principles. What is important is that food additive must be assessed as safe before being allowed in food. So, in fact, E-number is not a bad guy. E-number tells consumer that this compound has been assessed for the safety in use. And for risk assessment, we demand in the European Union several tests which can give base for documentation of the safety of the food additives. And these are described in the two guidelines. Scientific Committee for Food, who was the guarantor of, from scientific point of view, of safety of foods in European Union before EFSA, published its guidelines in 2001. This guidelines is now replaced by a guidelines published by EFSA in 2012. However, it is a transition period. If somebody prepared an application for food additive before the guidelines of EFSA have been published, of course, such a dossier is relevant and will be accepted. Also, when the re-evaluation of the safety of food additives is ongoing now in European Union, it wouldn't be reasonable to demand that they have to be tested according to the new guidelines. So the guidelines is still accepted. And then the safety assessment before authorization is done nowadays in EFSA, and EFSA asks its panel, INS panel, you have heard the name, this is panel on food additives and nutrient sources, to evaluate the safety of a chemical for food additive. So this is how it looks, the process, and now what kind of data are needed for review for experts who will assess the safety. Again, now I am referring to the guidelines of EFSA from 2012, and Birgit already mentioned some of those. Bernard was mentioning some of the demands for data from the botanical guidelines. We need identity of the substance and specifications, proposed specifications. We need data on manufacturing process, methods of analysis in foods, reaction and fate in foods, and case of need and proposed use and use levels. The last one is for exposure assessment. And please notice the green stars. Demands for data for identity of the substance and specifications. It is the same information which is required in the EFSA guidelines on safety assessment of botanicals and botanical preparations intended for use as ingredients in food supplements. And here the two assessments meet. And this is why also I can stay here and talk about food additives. Because we have the same demands for data in risk assessment for botanicals, for food supplement preparations, and food additives which are of botanical origin and are extracts from the plant material. Then, of course, huge part of such a dossier, there are data which are biological and toxicological data. We need to know what happens with the compound when it enters our body. So data on absorption, metabolism, distribution, and excretion, ADME data. Subchronic studies, because we do not eat a food additive only one time in our life. We eat it through whole life, and hopefully the long life and happy life. Genotoxicity data in vitro and in vivo, chronic toxicity and carcinogenicity data, and reproductive and developmental toxicity. Other studies may also be required to support the safety. It depends on the outcome of the studies which I already mentioned. There may be need for a study which checks, gives some information about the possible mode of action. For food additives like sweeteners, we will ask always for data on glucose metabolism in healthy subjects, also in subjects with diabetes, 2 types of diabetes, for example. You notice the red arrows, and I did it on purpose because these were the core studies always demanded in the guidelines of Scientific Committee for Food. They are not any longer core studies according to the guidelines which was published in 2012. Because if the compound is not absorbed or there is a negligible absorption, you need not to perform all these studies in support of safety. We have now a tier approach, and then it is up to the applicant to decide which studies are necessary. And another difference is that, for example, carcinogenicity study is not longer demanded to be performed in 2 species, only in laboratory rats, and with regard to the other endpoint on reproductive toxicity, 1 generation and 2 generation studies are not required, but applicant may decide to use the design of extended 1 generation study, which recently is also included in the OECD guidelines. So these are the demands for data. And Birgit already also talked about the importance of specifications. And I would say, I nearly can repeat what Birgit said concerning the food additives of botanical origins. We need adequate specifications. For the safety evaluation of the extracts, we should know what is the extract. So the extracts which is tested in animal studies should be the same as the application for authorization of food additive is. Because otherwise, the study does not function to support the safety of the food additive. And in special cases of extracts obtained from different sources or by use of different extraction method or different solvents, we can use read-across while assessing the safety, but only in case when the specifications of the extracts are adequate and we can see what compound is tested in one study and what was tested in another, if it is the same compound or very similar compound. So these are very important aspects. And then there is also a reason why I have these 2 nice plants, oregano. Oops, oh, sorry, I really damaged your ears. And I have another one, lemon balm. This is citron melissa. I hope it can go for this. You see, I have mentioned that there are some authorized food additives which are of plant origin, but here it is a special case, oregano and lemon balm extract. Why it should be different from rosemary extract, which is authorized as a food additive? Yeah, EFSA, so the Commission had got the request that such an extract should be authorized as a food additive, and it went to EFSA and finally to the INS panel. And this is about water-soluble plant phenolics present in these herbs, so extract, which is a water extract. But what about the dossier? What about the data which were given to support the safety of such an extract? There was limited chemical characterization of the compound in the extract. Specifications as proposed by the petitioner were not in line with what would be expected for a botanical or a botanical preparation according to the EFSA guidelines mentioned by Bernard Botex and Birgit. There were some compound of concerns, but they were not specified very well, so maybe threshold of toxicological concern principle could be applied, but if you do not have data, you cannot even try to apply such a principle. And there was absence on data on genotoxicity, reproductive and developmental toxicity, and long-term toxicity, chronic and carcinogenicity of oregano and lemon balm extracts. Considering all this, there was a negative, in a way, opinion, because altogether, with reference to the SF guidelines on submission for food additive evaluations, the panel concludes that due to the lack of an appropriate dossier supporting the use of oregano and lemon balm extracts as additives, the safety of oregano and lemon balm extracts at the proposed uses and use levels cannot be assessed. This compound cannot be authorized as a food additive because risk assessment cannot be performed because of lack of data. Even if I have no concern having these herbs in my kitchen and use them in food preparation in my kitchen and eat them. But risk assessment of food additives have to follow the several steps. As Birgit mentioned already, we have these steps. I am not going into detail on these steps. You are welcome to ask questions about them when we have a coffee break. What is important is that the outcome of risk assessment for a food additive is a health-based guidance value. And in case of food additives, usually we have this magic letters, ADI, and it is not anything else but acceptable daily intake. It is not advised daily intake or recommended daily intake. It is acceptable daily intake. And it is an estimate of the amount of a food additive expressed on a body weight basis that can be ingested daily over a lifetime without appreciable health risk. And it is usually established by applying an uncertainty factor, by default 100, but it can be different depending on the data, to the dose of the additive found in the toxicological studies to produce no health effects in the animals. This is the ADI. And finally, when we have the ADI, we have to compare the ADI to the exposure. Because if estimated exposure is lower than the ADI, an additive is likely to be safe if used as indicated. There is no safety concern. But if estimated exposure is higher than the ADI, there is a concern about safety. And then reductions in exposure are needed to comply with the ADI. But this is in hands of risk managers. Another possible health-based guidance value is a margin of safety approach. We will not say how much it can be consumed, but we can say that if we consider the estimated exposure to a food additive, to a compound which is candidate for a food additive, and the intake that did not produce adverse effects of the level has a certain margin, then we can say that it is also safe with this exposure to humans. And by this, I would like to end my presentation, and I'm open for your questions. And as I said, questions to food additives, for example, risk assessment, we can take them during the coffee break, because it is not food additive conference, but it is about botanicals today. Thank you very much.